Lesson 24. How to be a keen observer. How to be accurate. Have you ever climbed out of bed and the house felt like it was freezing? But after you showered, you stepped out of the bathroom and the house felt toasty warm? If you looked at the thermometer, you would have noticed that the temperature hadn't changed. What happened? Your senses told you that the house felt warmer, but you were wrong. Your body warmed up instead. Now, look at this illustration of two lines joined together with arrows. Does the line on the left look longer than the line on the right? You can use a ruler to measure each line if you like. This is an optical illusion. The angles make one line segment look longer than the other. The two line segments are actually the same length. In these two examples, we use measuring instruments to overcome a fault in our senses. The thermometer and the ruler make our senses more accurate. How to see more. Microscopes and telescopes also help our senses. Galileo was one of the first scientists to use a telescope. This is what he observed on January 7th and 8th, 1610. When I was viewing the heavens through a telescope, the planet Jupiter presented itself to my view, and I noticed a circumstance which I had never been able to notice before, namely the three little stars. Small but very bright were near the planet, and they made me somewhat wonder, because they seemed to be arranged exactly in a straight line when on January 8th I turned again to look. I found there were three little stars, all west of Jupiter, and nearer together than on the previous night. I therefore concluded that there are three little stars in the heavens moving about Jupiter as Venus and Mercury move around the Sun. Sidereus Nuncius, 1610. Galileo was the first person to observe the moons of Jupiter. There are many scientific instruments today that help us to observe things which our natural senses cannot see, including magnetic resonance imaging, MRI, to scan the inside of our bodies, and the Voyager spacecraft, which has sent back pictures to the planets. How to remember more. Have you ever woken up at night, looked at your digital alarm clock, and noticed that the numbers on the clock make a special sequence, such as 1212 or 123 or 222? A clock can only display a limited number of patterns like this. Why do we seem to wake up when there is a pattern and not when there is no pattern? Many people believe that this is more than a coincidence. This is known as memory bias. Our brain finds it easier to remember patterns. We forget things that have no patterns. Every time we wake up and see the numbers on the alarm clock and they have no patterns, our brain forgets all about it. Then we go back to sleep. Then, when we ask our memory, how many times have I woken up and seen a number pattern on the clock? It replies, almost always. But it is mistaken. How do scientists overcome the problem of memory bias? They take careful and complete notes. They enter data into a database. They snap photos on their work. They keep a journal of their progress. They keep records of everything because they know their records may tell a different story than what they remember. The story of Pierre and Marie Curie. In the late 1800s, Henry Becquerel discovered an accident that uranium gave off strange rays that could darken a photographic plate. Marie decided to make a systematic investigation of this mysterious uranium rays. She had an excellent aid at her disposal, an electrometer for the measurement of weak electrical currents, which was constructed by Pierre and his brother and was based on the piezoelectric effect. Results were not long in coming. Just after a few days, Marie discovered that thorium gives off the same rays as uranium. Her continued systematic studies of the various chemical compounds gave the surprising result that the strength of the radiation did not depend on the compound that was being studied. It depended only on the amount of uranium or thorium. Chemical compounds of the same element generally have very different chemical and physical properties. One uranium compound is a dark powder, another is a transparent yellow crystal. But what was decisive of the radiation they gave off was only the amount of uranium they contained. Marie drew the conclusion that the ability to radiate did not depend on the arrangement of the atoms in a molecule. It must be linked to the interior of the atom itself. This discovery was absolutely revolutionary. From a conceptual point of view, it is her most important contribution to the development of physics. She now went through the whole periodic system. Her findings were that only uranium and thorium gave off this radiation. Marie's next idea, seemingly simple but brilliant, was to study the natural ores that contain uranium and thorium. She obtained samples from geological museums and found that of these ores, pitchblende was 4 or 5 times more active than was motivated by the amount of uranium. It was her hypothesis that a new element was being was considerably more active than uranium, was present in small amounts in the ore. Fascinating new vistas were opening up, and Pierre gave up his research and joined Marie in her project. They found that the strong activity came with the fractions containing bismuth or barium. When Marie continued her analysis of the bismuth fractions, she found that every time she managed to take away an amount of bismuth, a residue with greater activity was left, and at the end of June of 1898, they had a substance that was about 300 times more strongly active than uranium. In the work they published in July of 1898, they write, "We thus believe that the substance that we have extracted from pitch blende contains a metal never known before, akin to bismuth in its analytic properties. If the existence of this new metal is confirmed, we suggest that it should be called polonium after the name of the country of origin of one of us." It was also in this work that they used the term radioactivity for the first time. After another few months of work, the Curies informed Académie des Sciences on December 26th of 1898 that they had demonstrated strong grounds for having come upon an additional very active substance that behaved chemically almost like pure barium. They suggested that the name of radium for the new element. Their laboratory was nothing more than a miserable hangar where in winter the temperature dropped to around 6 degrees. One chemist commented that it looked more like a stable or a potato cellar, and yet Marie admitted that one of our pleasures was to enter our workshop at night. Then, all around us, we could see the luminous silhouettes of the beakers and capsules that contained our products. How to be a keen observer. The story of Pierre and Marie Curie illustrates what it means to be a keen observer. Before microscopes and telescopes, men and women had only their natural senses and their memory to study the world. Science made slow progress. Gradually, scientists found ways to make observations more accurate, and in many ways, the story of science is the story of the instruments scientists have invented to observe the world. So, is this lesson about using measuring instruments? Not exactly. Being a keen observer is more than the instruments we use. It is a habit we learn, it is a goal. Why were scientists motivated to invent instruments in the first place? Because they desperately wanted to be more accurate. To be a keen observer, number one, learn to use scientific instruments to make accurate measurements. Two, keep complete records of what you observe. And three, observation is a habit. Become a stickler for accuracy. Exercises A. In the following questions, name a measuring instrument or method of keeping records which would help you to make these observations more accurately. Number one, how much rain falls in 1 month at your home? Two, if you didn't have a timer, how could you tell if the cookies you are baking are done? Three, how many volts does a AA battery produce? Four, how many hairs are on your head? Five, how many seconds of difference is there between when the sun set tonight and when it will set 1 week from now? Six, on average, how much money does it cost per month to use the light bulbs in your room? Seven, how much light does the brightest light in your home produce compared to direct sunlight at noon? Eight, if you were colorblind, could you design a test for measuring how colorblind you are? B, gather a group of friends or fellow students for the following activities. Number 9, ask everyone to listen quietly for 5 minutes and describe on paper every type of sound they hear. Arrange to have someone make sounds outside the room, such as banging two objects together or popping balloons. After several minutes, ask each person to read his or her list. Did anyone hear a sound that no one else heard? Is it difficult to describe sound when you don't know what is making the sound? Number 10. Ask everyone to perform some tasks, such as putting together a jigsaw puzzle or playing a board game that requires everyone to pay attention. This is to keep everyone's attention occupied. Arranging to have someone walk into the room and perform a common task, such as sweeping up dirt or emptying the trash can without attracting any attention. After the person leaves, ask everyone to write answers on a paper to the following questions. What was the person wearing? What color was his hair? What color was the broom he used? How full was the trash can he emptied? How long did he take to do his work? You can also make up other questions. If someone is unsure of what to answer, suggest they guess. Don't allow anyone to see what his friends are writing as answers. Next, bring the person back into the room and ask everyone to read what they wrote. Who was the most accurate? You may notice that some people remember things that are not true. For instance, they may remember the person wearing different clothes than they were really wearing. These are examples of memory bias. Sometimes our brains invent facts to help us answer questions we are unsure about. Number 11. Gather some objects ranging in size from an apple to a toy soldier or a piece of macaroni. Put these objects in a dark bag. Ask a group of friends to close their eyes. Hand one object around the group and allow each person to handle it without seeing it. Ask them to remember what the object feels like. Put the objects back in the bag and ask each person to try to find that same object in the bag again without looking. You can use a stopwatch to time each person to see who can find the object the fastest. You're testing each person's ability to observe and remember what things feel like. D. In these examples, explain what skills are being used and name a benefit each skill has. Number 12. Tea is made by steeping leaves of the tea bush Camellia sinensis in hot water. Tea connoisseurs search for choice rare teas in the same way that wine and coffee connoisseurs delight in fine wines or coffee beans. Choice rare teas have complex aromas and flavors. Carefully cultivated, the best teas are grown on small farms at high elevation. Tea merchants purchase chests of this tea at auction. They hire a master taster to sample the teas. Master tasters have cataloged the many teas of the world by their taste and aroma. Only the best teas have an intense and distinctive flavor. A master taster can often remember clearly a cup of tea he drank years ago. He will close his mouth, hold the tea in the back of the mouth, swallow the tea, and exhale through the nose, while keeping his mouth closed. Number 13. Agba lives in ancient Egypt all his life. He has seen his parents and other people look at the sun to see what time it is, but every time Agba looks up at the sun, it never really tells him what time it is. Agba also notices that when two people agree to meet at the marketplace at the 9th hour, often they show up at different times. He has found that if he looks at the length of shadows instead of looking at the sun, that the shadows are shortest in the middle of the day. He can use the length of the shadows to gauge how much time there is before the sun sets. His friends are surprised by his skill, but they don't listen to him when he suggests they look at the shadows instead of the sun. Number 14. Armand thinks his house is being invaded by large spiders. He's been trying to warn his mother about this. It seems like almost every time he goes downstairs in the middle of the night to get a drink of water, there is one on the sink or on the side of the refrigerator. His mother doesn't believe him. She says he is experiencing memory bias. He is just forgetting about all the uneventful times he goes down to get a drink of water and doesn't see a spider. He decides to keep a record of every time he goes down for a drink of water and whether he sees a spider or not. After 2 weeks, he shows his mother that he saw a spider 8 times out of the 10 times he went down. She agrees to call a pest control man. Number 15. Mr. Bascombe's job was to decode the secret message LSLONP. CJ QNSQFKI AOJONSG PBONHSJ RNOO. The secret agent who gave him this job said that the word might be sequoia. Mr. Bascombe remembered a code he had learned when he was a Boy Scout. It was called the key word code. Each letter of the alphabet was switched with a different letter of the alphabet, and he wrote out the alphabet, A through Z. Below it, he wrote the code alphabet, starting with the keyword sequoia and following the keyword with the rest of the alphabet, leaving out any letters which were already used in the keyword. Row 1, A through Z. Row 2, sequoia, A through Z. To decode the message, B. Bascombe must substitute each letter in the coded message with a letter in the alphabet that corresponds to it. For instance, the first letter in the coded message is L. Mr. Bascombe finds L in row 2 and then looks for the letter directly above it and sees P. He then writes down P as the first letter of the decoded message. Mr. Bascombe translates the coded message as papers in crack of General Sherman tree. E. Read the following story and answer the questions below. Percival Lowell founded the Lowell Observatory in Flagstaff, Arizona. He was obsessed with the idea that an unknown planet was disturbing the orbit of the planet Neptune. After Lowell died, the observatory hired Clyde Tombaugh to search for Planet X. Clyde found Pluto by taking many, many photographs with a special camera with a 13-inch objective lens built specifically for this search. He took 2 photos, 2 weeks apart, of each location in the sky where he thought Planet X might be. He then compared the stars in each photo pair of photos using an instrument called a blink comparator to see if he found any that moved, even slightly. On February 18, 1930, he found what he was looking for. Clyde became the only American ever to discover a planet. 16. Can you find the planet Pluto in the photographs taken by Clyde Tombaugh in 1930? Pluto is a very small dot towards the center of the first photo and disappears in the second photo. References. The Story of the Curie Family was taken from Marie and Pierre Curie, The Discovery of Polonium and Radium, a lecture by Fanny Froman at the Royal Academy of Sciences in Stockholm, Sweden on February 28 of 1996, translation from Swedish to English by Nancy Marshall Luden. Used with permission. Visit http://nobelprize.org/physics/article/Curie to read the full essay. If you want to learn more, watch the movie Madame Curie, 1943.